Okay, so we're going to look at some bike manufacturer where B is the number of bicycles produced from F frames and T tires. Every bike needs exactly two frames, two tires and one frame. So draw the isoquants for these things. Well, you should think immediately that when you hear every bicycle needs exactly, you should think, okay, we've got fixed proportions, so we're going to have Leontief isoquants. So if we have two tires and one frame, we can make one bike. If we have one frame and four tires, we can still only make one bike. If we have two frames, or two tires and two frames, we can still only make one bike. So all these things have to lie on the same isoquant, which is going to be Q equal 1. Okay, so any combination, any points on there, let me make one bike. What about looking at the set, if we want to make two bikes? Well, we need two frames and four tires. And if you made some other points, you'd see that you have another L-shaped thing, which gives you Q equal 2. Okay, so they're what the isoquants look like. You need these inputs in fixed proportions, and you can't make a bike with two frames and one tire. So that's what they look like. What would the mathematical expression for the production function for bicycles be? Well, the way you write these Leontief things, or these kind of fixed proportions thing, is Q. So your output is the minimum value of frames and a half tires. Why? Well, let's look. If we have 4 tires and 1 frames, so if we have 4 and 1, then Q is equal to the minimum of 4, sorry, what did I say, 4 frames and, yeah, Q is minimal to the, so we've got 1 frame and 4 tires. Well, that tells us Q is equal to the minimum of 1 and 2. Q is equal to 1. Okay, so that's how these things work. We need two tires per frame. So we take a half T and 1F. What can we say about the returns to scale here? Well, remember, to look at the returns to scale, you check what happens when you double all inputs. So here we have f of k and l is equal to the minimum of f and a half t. So that means twice f of kl, twice f of kl equal to twice the minimum of f and a half t. So that's what happens, that's what double our output is. What's double our, if we double our inputs? Well, if we double our inputs, f of 2k and 2l, well, that gives us the minimum of twice f, sorry, k and l, I should be putting in f and t, but you get the idea. It gives us a minimum of 2f and 2 over 2, so just t. Okay? So are these the same thing? Well, they are. So you can just take the 2 out of this, and you go back to having twice the min of f and a half t. Okay, so this was double our. This is double our output. So this is twice our output, and this is what happens if we double both of our inputs. So because doubling our inputs gives us double our output, we have constant returns to scale, which is the same for all these Leontief technologies.